Hi everyone, welcome back to my channel. In this video, I am going to solve Surface Chemistry CSIR NET previous year questions from 2021, and also I have solved 2011 to 2020 previous year questions. That link I have mentioned in description. Please go through that. Now let's move to the question. Question 1 asked in CSIR NET June 2021. The volume of nitrogen gas adsorbed at STP to form a monolayer on a surface solid for a solid surface is 22.4 cm³ per gram. If the area occupied by one nitrogen gas molecule is 16.2 Armstrong square, then the surface area in centimeter square per gram of the solid is close to. Here four options are given: 1.2 into 10 to the power 7, 9.8 into 10 to the power 5, and 1.2 into 10 to the power 5. Then option D is 9.8 into 10 to the power 8. Now let's see the solution. Here given volume of nitrogen gas adsorbed at STP for monolayer formation is 22.4 cm³ per gram. Area occupied by one and two molecule is 16.2 Armstrong square. Now we will solve by step. Step by step. In step 1, find the number of molecules adsorbed. At STP 22,400 cm³ is equal to 1 mole. So 22.4 cm³ that equal to 22.4 divided by 22,400 that equal to 10 to the power minus 3 mole. Number of molecules 10 to the power minus 3 into 6.022 into 10 to the power 23, that equal to 6.022 into 10 to the power 20 molecules. Now we'll see the step 2. Convert molecular area into cm square, centimeter square. 1 Armstrong is equal to 10 to the power minus 8 centimeter. Hence 1 Armstrong square is equal to 10 to the power minus 16 centimeter square. Therefore 16.2 Armstrong square that equal to 16.2 into 10 to the power minus 16, that is equal to 1.62 into 10 to the power minus 15 centimeter square. Now in step 3, calculate total surface area. Surface area is equal to 6.022 into 10 to the power 20 into 1.62 into 10 to the power minus 15, that is equal to 9.76 into 10 to the power 5 centimeter square per gram, that is equal to approximately 9.8 into 10 to the power 5 centimeter square per gram. So final answer is 9.8 into 10 to the power 5 centimeter square per gram. So here correct option is option B. Now we'll see the second question. This is asked in CSIR NET June 2021. The surface tension of a dilute soap solution is lower than that of pure water because here four options are given. Option A, soap molecules accumulate more at the surface than in the bulk solution. In B, soap molecules accumulate more in the bulk of the solution than on the surface. And in option C, the soap molecules aggregate uniformly in the bulk and the surface. And option D, soap molecules form micellar structures at low concentrations. Now let's see the solution. Now we will see explanation for this. Soap is a surface active agent, that is surfactant. Its molecules have, one is hydrophilic water loving head and another is a hydrophobic water repelling tail. When dissolved in water, soap molecules preferentially absorb at the air-water interface surface rather than remaining uniformly disturbed in the bulk. This arrangement disturbs the strong cohesive forces, hydrogen bonding, between water molecules at the surface. As a result, the surface free energy decreases, hence the surface tension decreases. Why the other options are incorrect? In option B, Option B is incorrect because if soap accumulated more in the bulk, it would not significantly reduce surface tension. Option C also incorrect because soap is not uniformly distributed. It preferentially absorbs at the surface. And next, option D also incorrect because Micelles form only above the critical Micelle concentration CMC. At dilute concentrations below CMC, soap molecules mainly accumulate at the surface, which is the reason for the decrease in surface tension. And correct option is option A. Here, soap molecules accumulate more at the surface than in the bulk solution. So for this question, correct answer is option A. Now, let's move to the third question. This also asked in CSIR NET June 2021. In a Langmuir type adsorption, a solid absorbs 0.25 milligram of a gas when the pressure of the gas is 50 bar and zero point 0.2 mg of the gas at 20 bar pressure. The percentage of surface coverage at 50 bar is close to option A 75, option B 38, option C 57 and option D 83. Now we'll see the solution. For Langmuir adsorption isotherm, theta is equal to Kp divided by 1 plus Kp. Here theta is fraction of surface covered and K is Langmuir constant and P is pressure. Also, the amount adsorbed is x is equal to xm into theta, where xm is the amount required for complete monolayer coverage. Then we'll solve it as step by step. In step 1, use the given data. At P is equal to 50 bar, 0.25 is equal to xm into 50k divided by 1 plus 50k. At P is equal to 20 bar, 0.20 is equal to xm into 20k divided by 1 plus 20k. Now take the ratio 0.25 divided by 0.20, that is equal to 50 into 1 plus 20k divided by 20 into 1 plus 50k. 1.25 is equal to 5 by 2 into 1 plus 20k divided by 1 plus 50k. Since 5 by 2 is equal to 2.5, 1 plus 20k divided by 1 plus 50k is equal to 0.5. So 1 plus 20k is equal to 0.5 plus 25k. 0.5 is equal to 5k, and then you will get a k as a 0.1. So k is equal to 0.1. Now we'll see the step 2. Calculate surface coverage at 50 bar. Here theta is equal to Kp divided by 1 plus Kp. That is equal to K is 0.1 into 50 divided by 1 plus 0.1 into 50. That is equal to 5 by 6. That is also equal to 0.833. Now we will see the percentage surface coverage. 0.833 into 100, that is equal to 83%. So answer is 83%. Here correct option is option D 83%. Now let's move to the fourth question. This is asked in CSIR NET June 2021. Liquid A has half of the surface tension and twice the density of liquid B at 30 degrees Celsius. The contact angles of A and B are same. If A rises 10 cm in a capillary, then the rise in centimeter of liquid B in the same capillary at the same temperature will be equal to, here 4 options given, 60, 10, 40 and 20. Now let's move to the solution. For capillary rise, H is equal to 2 into T into cos theta divided by R rho G. Here H is height of capillary rise and T is surface tension and theta is equal to contact angle and R is equal to radius of capillary and rho is equal to density. This is the formula for capillary rise. Now we'll substitute values. Since the same capillary and same contact angle are used, H directly proportional to T divided by rho. Here given TA is equal to half TB, rho A is equal to 2 rho B and HA is equal to 10 centimeter. Now HA divided by HB, that is equal to TA divided by rho A divided by TB divided by rho B, that is equal to TB divided by 2 divided by 2 rho B divided by TB divided by rho B, that is equal to 1 by 4. Hence HB is equal to 4HA, that is equal to 4 into 10 is equal to 40 centimeter. And final answer is 40 centimeter. Here correct option is option C, 40 centimeter. I hope you understood these concepts. In next video, I will solve some more previous year questions. If you like this video, please like, share and subscribe to my channel. Thank you. Have a good day.